Whee! Hello, everyone. Welcome to Learning Space. My name is Nicole Gallucci. As you see, we only have the one window this time, which is weird for me. But that means all the text should work. So obviously, if you can't hear me, please yell at me in the comments. I'm Nicole Gallucci from CosmoQuest, and I'm here with Colin Wilson, my coworker here at the STEM Center at SIUE, Southern Illinois University, Edwardsville. And we are going to be doing some science demos and talking about science resources for the classroom and for informal educators, and especially if you're in Southern Illinois, how you can get that stuff from us. This guy's awesome. So we are going to get started. First, I want to remind you guys, you can share the link. That will be awesome and help us out a lot. You can leave us a comment on YouTube. I'll be checking that. Hi, James. And, oops. And on the Hangout page itself, but if you guys can maybe keep it in one spot, decide amongst yourselves. And then the Q&A app for Hangouts as well, so you can interact with us, say hello, leave a comment, ask a question. That'll be really cool. So let's just get started. I know you have lots of fun demos, science demos.
I do have some demos planned. So
science. We
have a bunch of stuff here at the Science Center, or the STEM Center, so I just grabbed some that looked like they'd be fun.
Yeah.
So this is the fun one that I do a lot with educators. So, you know, people watching Learning Spaces probably know the answer to some of these. So I have a ping pong ball, and I'll just ask Nicole. It says China on it? I assure you it's a ping pong ball.
It's a ping pong ball, not China.
Not China. They are hard to tell apart sometimes, but if I drop this ping pong ball / China, it's going to go, Nicole, up to my hand, farther than my hand, lower than my hand.
Lower than your hand.
Lower than my hand.
That's my hypothesis.
Right.
Yeah, I didn't even make the video.
It got a little bit up there.
A little bit? Okay.
So,
let's try it again.
So,
we go just above the lower third.
Not quite, not quite. So, you know, that's something called the conservation of energy. I drop it from a certain height, and it goes down, and it retains some of the energy, but a lot of the energy is lost. So that also should happen with this thing. It's a little popper. Oops.
Rubber thingy.
It's already popped. It's a little rubber cup, and if I fold it inside out.
See, I'm not making it up.
Yeah, there's China.
Right.
This one says 5. This is 5.
Okay.
So if I drop 5, like so, it's going to pop and also not go quite.
It just went horizontal for those of you watching at home or
it went horizontal,
on the podcast.
But again, not as far as my hand.
Mm-hmm.
So we lost some energy, even though this thing snaps and gives us some elastic energy back. So if we combine these, Nicole, are we going to get up to my hand, above my hand, lower than my hand? They both went lower.
Okay. So you would think together they might still be lower.
Right, right. So we'll try.
Ooh.
Neither.
Neither. Broke.
Okay.
Okay, let's try one more time.
This might not be high enough. Let's try.
Yeah. Okay, did that leave a crack? Or are those pre-existing? You didn't hear that. It just bounced off the ceiling.
I think those were there before.
Those were there before us. We're gonna go with that. So that is an example of what we would call a discrepant event.
Yeah.
Can you explain that a little bit? Because this is a term I'm recently becoming.
A discrepant event is something that so there are lots of things that are surprising, new things that are really interesting, but there are some things that you think you know the answer, and then it turns out to be something else, and that's a discrepant event. Right. So. Looking at the bouncing of both these things, you think you know what the combined effect is going to be, but it's something totally different.
Right, right, right. Can you tell us why this actually snaps back and goes, well, hits the ceiling and scares the poo out of me?
Yeah. So the reason is that this little popper thing, when it snaps, the first time I snapped it, it popped up and didn't go as high as my hand, because it lost some, not all the energy stayed with this thing. If all the energy stayed with this thing, it should leave from my hand, go right back up to the same height. But some of it's lost, and it goes into the earth and shoves the earth a little bit, but that happens all the time. Yeah. It all evens out. Maybe it heats up this table a little because the elastic energy turns into thermal energy.
My desk is warm.
Yeah, that's why your desk is warm. Just constantly getting it.
Thanks.
So some of that energy is lost. When I combine them, it puts some energy into the desk slash earth, but the same amount of energy into a ping pong ball, which is much smaller. It's only the size of China. So it goes rocketing up to the ceiling because it gets a lot of elastic energy pumped into it, which before it was deceptive how the amount of energy we had because it was going into something huge and
Didn't
relatively
even notice
immovable.
the Earth shift under China. Yeah, so we have lots of fun little and not so little things like that around here. And although I live here at the STEM Center, we don't get to talk about it much on CosmoQuest. So I'm excited to talk to you about that. Maybe you can tell us a little bit about what the STEM Center is and does.
Sure. So the STEM Center.
Oh, sorry. STEM is science, technology, engineering, mathematics. I know that sounds like I'm over-explaining for some of you, but some of you may not be familiar with that. So let's say that first.
I was going to do the same.
Oh, okay. There you go.
I learned recently that when it first got proposed by the National Science Foundation, they were calling it SMET, which is the same letters, and they just say, well, we'll just put them all together. And somebody said it'd probably be better if it's an actual word. And STEM has connotations of growing and learning
like
and students. Yeah, and SMET sounds awful.
Sounds like smut. Terrible.
So at the STEM Center, it's a research center. So we do things like CosmoQuest, where we have citizen science projects that are actually generating new science. It's a education center where we assist teachers. That's a lot of what I do. And have resources for them, have curricula for them, have different things that they can try in their classrooms to improve their students' experience. And then we have outreach as well, which is actually going out and delivering. So we have people who go out and will do after-school programs, who will do sort of cameos in classrooms, who will do professional development for teachers. That's something that I do too. And so we just generally try to engage all the educators and community in Southern Illinois with different STEM-related topics.
Yeah, it's a great resource, and kind of wishing I could take the camera back to the storeroom and show everyone. Maybe at the end I'll try on my iPad, because it'll probably break everything, but we'll do it later. It's like this magical wonderland of science toys, and where last place I worked, we had a little closet of science toys that we used for astronomy outreach. This place is just like...
The last place I worked, we had a large room like this, but it was very messy and all over the place. So this is both organized and large.
Yes, so. Thank you, Elizabeth, who was a recent Learning Space guest who helped us organize a lot before you came. So, yeah. So why don't you tell us a little bit more about your background in science education?
Sure. I recently started at the STEM Center. I started in August.
Yeah, you're a newbie.
That's true. So I started just recently here. Before this, I was at the Science Center in St. Louis. And before that, I was not an educator at all. I was a researcher. I figured, you know, I liked science so much that I wanted to be doing it all the time. And so I actually had a rotating series of things that I wanted to do. When I was a little kid, I wanted to be a paleontologist, no questions asked.
They might be giant song.
Really?
About that.
About that?
Yes.
Because everyone likes
I'm a paleontologist.
Yeah. I mean, I was like really serious, and I also was not big on looking up pronunciations, so I still have a lot of weird pronunciations for dinosaurs. But my brother and I we're both really, really interested in it. My sister is studying paleontology now, so it's in the family.
Cool.
So I definitely want to be a paleontologist. There was nothing else that was interesting to me. And then I took a really awesome astronomy course in high school with my teacher, J.R. Kandasta, who was amazing and got me really, really interested in astronomy. So then, paleontology, whatever, I want to be an astronomer. And then I started doing astronomy and was taking some geology courses as part of it, and realized that I was really liking the geology courses and not so much the quantum mechanics stuff, which was very hard. And so I decided, okay, well, I want to be a planetary astronomer.
Mm-hmm.
And so I went to grad
Yeah.
school and started doing that, and then realized, this is really great. And I was doing projects with meteorites, and it was very interesting. But I thought, I really like from my geology courses going somewhere and knocking something off with a hammer and taking a chunk of it. And I really like touching stuff. So I guess I just want to be a straight up geologist.
Oh, no more. Yeah, yeah. There's no missions to Mars yet, so you
Right,
can't really
right.
fulfill that.
No manned ones.
No human. Yeah, yeah.
But and I did all this. I got to my master's and kind of finished with my master's and thought, what do I want to be doing? And realized that I liked learning about all these science topics, but I really, really liked explaining them to people.
Mm-hmm.
So I started working at the Science Center in St. Louis, doing education outreach stuff, and in particular there's a teen program there that's a really great program, the YES program. And I worked with teens there and covered a bunch of science topics, and then I started here and started working more with teachers to pass on that knowledge and help think of creative ideas to engage different topics.
Wow, very cool. That is very cool, and it sounds familiar.
Yeah.
I like doing science, but I really like explaining it, and having trouble keeping focus on one
Mm-hmm.
tiny little area of research.
Mm-hmm.
So I totally get that.
Like the universe.
Well, if only, yeah. If your dissertation was the whole universe, you'd never graduate.
Right.
Never ever graduate. So. Awesome, awesome. So what did you do for your master's in planetary? No, in geology, sorry.
In geology, I went camping in Quebec for about a month, which was really fun, and gathered up samples in a field area of a pretty rare kind of rock called a northicite.
Okay, I've actually heard of that.
Really? Yes,
I don't
you
know
have.
much geology, but...
You have, because it is hardly found anywhere. It's found in this sort of series of deposits, one in the northern hemisphere, one in the southern hemisphere, that if you match up the continents again, they all line up into a northern trend and a southern trend.
Gotcha.
They all, there was a period billions of years ago where there was a bunch of them that formed and then they stopped, and there were none before and none after, so it's sort of mysterious. So you can only find them in a couple places, and also like half the moon, because the highlands in the moon.
That's probably where I've heard of it then.
The highlands
from
of the
Emily
moon
Lakawala.
are all in northicite. And actually in J. Arkandasta's class, I should let him get some royalties for all the promotion I'm doing. But one of the things that still I remember vividly, like hearing this and thinking like, wow, okay, was there's highlands in the moon that are this white type of rock, and that rock is called a northicite. Mm-hmm. And here's a chunk of a northicite. Right. And then, in the lowlands in the moon are basalt, and here's a chunk of basalt. And so the idea that the moon, which is this relatively airless, faraway body that's, untouchable and all this stuff, is made of the same stuff. The rules are the same there as here. Is really exciting and interesting.
Cool. Very cool. So what brought you here to the STEM Center? We just seemed so lovely in our little basement.
You did. You did. It's I liked the idea of serving a large community. That's what really excites me here. That every day I have parents coming in who are homeschooling their kids, and they want some classroom equipment. Some teachers coming in that want to either try out classroom equipment and then talk to their administrators about getting it, or they have a little bit and they want to do something special just for one lesson, so they get something really interesting to try. I work with people making up curricula. I work with middle schoolers doing science projects. I advise people, test out things, organize, and it's sort of, you get to do everything, and you get to support a really wide area with it.
Do you want to try another demo, maybe?
Sure. I have a nice.
And I will remind you guys to hi Guido, to also send us your comments and questions. And Guido just posted, "I am a paleontologist. They might be giants." Yes, that's the song I was singing in my head. So sorry, Guido's over here on YouTube. I posted a great workplace tour. Oh, okay. So Guido's asking. So since I mentioned doing a brief workplace tour, I did do a CosmoQuest workplace tour. That video is private, and you only got access to it if you took our user survey, which is part of my citizen science motivation research that I'm doing. Do I plan on remaking it with Google Glass? That's a good idea. I may have to think of that, especially when we move, which we'll get to in a bit. Michael says hello. James says science will put your eye out depending on the bounce. And does science-based poo differ from civilian poo? I think that's because I said something about poo. Probably. Anyway. Don't listen to me. Listen to this guy. All right. Thanks, you guys. Sorry. Just catching up on the comments. So, yeah, let's go ahead with another demo.
Sure. And this demo, I think, James's question, which I think was maybe he didn't expect a specific answer, but I think it's an interesting thing to think about, science versus civilian. And I feel like you can do science in a lot of different areas.
Mm-hmm.
One of the chemistry activities I like really doing is a kitchen chemistry demo, which involves combining all the different ingredients with cake to find out what are the exact reactions in cake that if you want to have a fluffier cake, what do you need to add more of? And you sort of,
That's awesome.
Back hack, like make your own recipe for a cake. And
We're going to do this, right, for Tea at 10?
Yeah, we should do this.
Okay.
We should do this. So this is one.
This is not cake.
This is not cake. This is called a polydensity bottle. This is a demo that I didn't know about until I came to the STEM Center, and I really, really like it, so I pull it out a lot. But the idea is that there are, you can see, so there's some clear liquid. In the midst of that clear liquid are some white beads and some red beads. And this is just in a 2-liter soda bottle. So if I shake this up, something cool is going to happen. It's
It's a party!
They will separate into
that's cool.
white and red beads. And then the best part happens. They come back together. So there's two parts to this.
Whoa. Okay, that's been sitting on the desk for like a year, and I've never actually seen someone do it.
Right?
How lame am I?
So the question with this is...
Oh, and these are coming down. Yeah.
Yeah, they come back together. Because they started off in the middle.
Oh my gosh.
So they have to end up in the middle.
What the hell? I mean, heck.
So the question is, why does this happen?
Tell us why. Or make me guess why. It's the clear liquids are different things. Oh, I also have the sticker pointing at me. It's fine.
Well,
it's fine.
Okay.
I probably would have guessed that anyway.
Well, you can tell two things. So
because when you shook it up, it was cloudy, right? Like
it was a little cloudy. Yeah. So things have buoyancy and they float at different levels depending on the liquid. So if the buoyancy is changing, that means that the liquid's changing.
Okay.
So in here, first of all, the first step is that they separated because they are beads of two different plastics. These are not just white beads, they are UV sensitive beads.
I have a flashlight for that.
There you go.
There we go.
So, yeah, and it
this is why I grabbed. I have this in my. I did this for you guys in a previous episode. With
you don't need
UV
to
beads.
explain. Everyone has a UV.
Everybody has a UV flashlight in there, and everybody has a meteorite in their purse.
Exactly.
So there you go. A few of them have changed.
Yeah. So some of them have changed sort of reddish. So they're UV sensitive, so it's a different type of plastic than the red ones. So when we shake it up, we have some that are more buoyant than the liquid and some that are less buoyant than the liquid. And the liquid is a combination of isopropyl alcohol, water, and salt. And water and isopropyl alcohol are mixable. As anyone who is over 21 and you order a drink with ice in it, and then your drink gets watered down as the ice melts, you don't get separate layers. So
whiskey far less enjoyable.
Yes. So water mixes with isopropyl alcohol, no problem, but salt water does not.
Oh, okay.
So they mix up, but as the salt sort of makes its presence felt, for lack of a better term, it starts forcing its way in and makes them not cooperate. So first you get a salt water alcohol mixture, and then
Mhm.
you start getting salt water and alcohol, and the salt water goes to the bottom.
Okay.
And both sets of beads are more buoyant than salt water, and the alcohol goes to the top, and both sets of beads are less buoyant than alcohol. So as they start separating into two separate liquid regimes, they sort of push things back together.
So how would an educator use this in the classroom then?
Well, this is another example of a discrepant event that things are floating. You think you know what's going to happen when they float. You see what it looks like here. If you mix it up, you expect them to end up in the middle,
right,
like most things. So that's a discrepant event, and it's also one that inspires something else that we talk about a lot called inquiry-based learning. So just like I did with Nicole, she said, so why does that happen? And I said, why do you think it happens?
I want the answer, guys.
It's something that is contained both container-wise and
Mhm.
also in what's going on. There's no, you can shake it up, you can do one thing, and then you can observe. And so
Right.
you, as an educator, you have some control. You can make sure no one's going to lose their eye.
Like with the ping pong ball.
Like with the ping pong ball. But it has a lot of open-endedness
Mhm.
to it that puts the control of the lesson, of some parts of the lesson, into the hands of the learner.
Cool.
So it makes them more engaged in it. I think everyone, if you like science, if you don't like science so much, if you do it every day, if you just kind of flip through the science section of the newspaper every once in a while, probably your least favorite part of science class was doing worksheets for like an hour.
Yeah.
That's that's boring. Who wants to just
And then how much of science is inputting data?
Right. Well,
when you get older.
yeah. You have to do that, but it's at least new. You're putting in
Right.
data that no one's put in before.
Right.
You're
Right.
making graphs that no one's made before. So doing things that no one's done before and exploring on your own is what real scientists do. And so you can model that in a semi-controlled way with, in a classroom by doing something like this.
So teachers can come here, so a place like this. We were talking about this the other day. I don't know if there's even a list of other places like our STEM center here. I mean, that's something we should look into.
There is some, and
curating.
There's a Google map that that tags all of them, but they are sort of. It's not like.
There's no one model for what a STEM center is.
Yeah.
Right?
Yeah.
They don't all have the same stuff.
If you say there's an education department in SIUE,
okay,
that they're roughly similar to all the other education departments. Maybe they fall into a school of education. Maybe they're in a school of arts and science.
Mm-hmm.
Maybe they have 5 faculty. Maybe they have 20 faculty. Maybe they have a externship. Maybe they don't. But they're all sort of structured the same. STEM centers are not that way.
Right.
Sometimes they're attached to museums. Sometimes they're attached to universities. Sometimes they're independent. Sometimes they're an extension of a school system. It really depends on the area. But they do all share this common mission of encouraging STEM and being a resource for educators.
So here, for this one, teachers can come here and not only get ideas, because I mean, a lot of this stuff the UV beads you have to kind of order online, but a lot of the stuff you could get in the store. So they can come here to get ideas and the actual equipment to either buy or rent from us.
Yeah, most of it is free. This would be free because they can take it, they can use it in the classroom, and they can bring it back. And
as long as you bring it back, it's free.
Oh yeah, as long as you bring it back. Some things, if you need to get just some baking soda, you can get that, and we'll just charge you. We paid $5 for the box, and you're using 1/100th of it, so give us a nickel. So we do that, and a lot of it is the expertise. We know how these things work, and we can explain the science behind them. So you can, some people are looking, and maybe they got a mini grant, and they're saying, I think I want to get this saltwater powered car, and I just got some money, but I don't know if it's going to work well. And so we'll borrow ours and test it out and see if you like it, and then get your own.
Yeah.
Or they say, we don't have any money, but I want to do something new. Then they don't need the car for 365 days of the year. They need it for a week, and so they borrow it for a week, and they bring it back, and someone takes it for another week, and they bring it back, and all this stuff.
It's a lending library of science goodness.
Yeah.
Science demo
Yeah.
goodness.
And it is very large.
Yes.
And extensive. And, you know, there are, and lots of times people ask for things, like someone asked the other day for a spectroscope, and we have the diffraction glasses.
Yeah.
And we have a spectrometer that hooks up to a digital readout. But we don't have just a tube with some demarcations on it that you can look at it and tell what the what gas you're looking at or whatever. So I said we don't have that, but we probably should. So I spent some time today shopping around and looking for which ones we want to order, because people have asked for that, so we know it's a need. So we'll get one, and then the whole.
Wait, are these like the gas tubes?
Well, we have the gas tubes.
We have the gas tubes, but we have the glasses to go with it. Okay,
right,
I see what
right.
you're saying.
And so the glasses, you can say.
You can see the lines, but you can't measure.
Yeah, yeah. There's a bright yellow one, and there's a bright green one, but to tell that there's a bright one at 760 angstroms or something, you need a spectron or a spectroscope.
Right, yeah.
So that's something that people asked about that we didn't have, and so. You know, we've got some money. We'll shop around and see if we can get one.
So you're the resource center manager, which was a position that went unfilled for far too long around here.
I think it was shared.
It was shared. Maybe that's it. It was shared. I don't know. I'm just the post. I don't know what's happening.
So
you've really brought it and made a thing.
My understanding is that everyone was doing it kind of in their spare time, and nobody has spare time.
Yeah.
So
yeah.
It wasn't really getting done. But yeah, so I can take some time and shop around for spectroscopes or.
I know you want to work on there's actually a dearth of astronomy materials here.
Yeah.
We can definitely work on bringing some more astronomy material, which is sad because Pamela and I live here.
Mm-hmm.
But most of my demos are made of crap that you get at the grocery store.
Right.
But we can really work on getting some higher quality astronomy stuff.
Yeah.
Here as well.
Yeah. And that was the thing. We looked into. Well, let's get some like hands-on astronomy models, and and most of them this is good, but it does the same thing as a styrofoam ball and a stick. So
right.
Let's just stick with that.
But we can have a catalog of things that can be done with a styrofoam ball and a stick.
Sure.
And teachers can.
which brings me to the other part of what we do here, where we have sometimes people come in for materials and sometimes they come in for consultations. Mm-hmm. So they'll come in and say. I want to do something with an eclipse, but I don't have an eclipse model. Do you guys have one? And I'll say, well, you don't need one. Do you have Oreos? Do you have, we have some styrofoam balls you can borrow.
I did the Oreo one at Geek Girl Con.
Yeah.
Well, the moon phase one, but yeah.
That was good because then we had Oreos in the office.
We had so many Oreos. Well, that was when Pamela did it because she bought too many. That's okay. So we got a comment from Guido. Saying when you put STEM Center into Google search, SIUE comes up as the second result. Yay! That may also be because we're connected to CosmoQuest, and you probably have CosmoQuest in your search history too.
Well, that's why we're the front runners.
That's why. Oh, okay. Not just on his browser. You're saying in general.
In general.
Okay. But yeah, if you want to check out the website, so you can either Google STEM SIUE, and that'll take you to our official university website. However, people here have been working really hard on a WordPress-powered site. Big surprise. Again, since we share server resources with CosmoQuest. It's a website called stemideas.org. I'm very happy they got that domain. Mm-hmm. Whoever was clever to come up with that. And so what the building here is it lists the research that we do. Oh, what do you want to point out?
Oh, the Resource Center.
Here we go. Resource Center. Tab.
And then there's a button there for Browse Library. And you can go on there and search things by tag. So the ones on front there, we have a large collection of Vernier Lab Quests, which are handheld computers that have different probes that plug into them.
Okay.
But if Nicole was doing an astronomy outreach thing for...
Oh God, you're going too fast for me.
Well...
Informal, is that... That's
yeah, informal.
Okay. Sure. Yeah.
And she wanted, books, so or whatever we have, then she can search. And like I said, there's like we said, there's a this is not our strongest suit at the moment, but we do have some stuff.
Stars and Planets, Astronomy for Dummies. Mm-hmm. I love books. Oh, we have an eyepiece. Really? Where is that? I'm like, there's an eyepiece that isn't part of my 8-inch telescope.
Why, Nicole? It's in the STEM Center.
Oh my gosh! No, I need a red angle. That's what I'm missing the most. So, and a green laser pointer. Excellent.
So people can look on here if they need ideas, and we have a lot of these book resources that they can look at, and they can also come in for a consultation and say, yeah, I want to do an eclipse activity. Well, like I have a great activity that you can do with just the stuff that you have in your classroom right now. Or one teacher came in the other day, she wanted to do something about renewable energy. And she wanted to really touch on everything. And so I said, well, we have this toy to play with, we have this, and this is, you might structure your lesson plan like this. And, she gave me feedback on, well, normally I do it like this. And so we came up with a lesson plan for her to introduce renewable energy in a really hands-on way, and then an inquiry lesson to go after that for them to explore things on their own, to look at the best practices for renewable energy. What's the best wind turbine design? Does it matter for this hydroelectric wheel if I use hot water or cold water or something like that?
Cool.
So they come in sometimes with just a blank slate,
yeah,
and we can help them with that. They come in sometimes with, I want to do this topic, what have you got? And we walk through some things. Or they come in and say, I looked on your online inventory, I really want the water cycle model.
Mm-hmm.
And say, great, we got that. Have you also considered the polydensity bottle that talks about different changing buoyancies and different densities, which relates to atmospheric conditions, and you could tie those two together.
Cool, very cool.
We try to have people leave with more things than they thought they were going to leave with. And
yes.
That way
I've
we know we're
seen
encouraging
that
them.
look of they leave with the bin
Mm-hmm.
of stuff, and it's like, okay, and especially with the student teachers. So we serve the student teachers who are in the education department here, and they have the doe eyes, the deer in headlights look, and they're like, okay, I'm gonna do this now.
That is an important group that we work with, because a lot of teachers want to change, but they have a way that they're comfortable doing it, and so it is more difficult. And I really don't think you should, if you like inquiry, you like discrepant events, don't change your whole curriculum. Try one lesson, and then next year try two, and then. But with student teachers, you can also, they're about to generate their own curricula, what they do every year, and if we can work with them while they're still student teaching, then by the time they're have their placement, then it'll be already ingrained, and they can get off and running, and we can sort of help the next generation of students that way.
Cool. I want to ask you about next gen science standards, but I think we should do a fun thing first.
Okay. How about a game?
Okay. I'll lose.
Okay.
I guarantee you I'll lose. Ooh. So I was watching him behind the scenes. I was watching him put all the stuff together this afternoon, and I'm like, I'm so excited! We're gonna play. Is this the one where we need more of the table?
Yeah,
on camera?
I'll have to show the
Okay. Hang on, you're getting a little dizzy. I'm gonna put this webcam up and point it at the table.
So
what?
The so this is the shell game at the carnival. So I have
You're gonna hustle me, aren't you?
I am. That's what the shell game's all about.
Be skeptical.
I have 3 cups, and they all look the same, and I'm going to put water, just a little bit of just tap water, into one of these cups.
So he was actually rolling that thing with tap water on a giant cart across.
Water's heavy.
I don't think I had to carry.
So I'm putting the cap on so you can't.
I'm gonna get water all over my desk.
Maybe I.
At least it's not mud like I did for the comment.
Oh yeah. I was listening to that happen, and thought it's gonna be in this. This might be too easy if I can't get this looking the same.
I won't look.
Give me patter. I need patter.
What?
Just talk.
Oh! You should have said vamp.
Vamp?
I know how to vamp.
Yeah.
So behind us, we're inadvertently. we are packing. If you're wondering why there's boxes behind me, we are packing. We are getting ready to move. We'll talk about that briefly, I'm sure. So yes, I'm not going anywhere too far, but we are moving on to a different spot on campus. Hence
Right.
the boxes.
And that's another thing that I'm largely in charge of. So.
Tagging everything, make sure it doesn't get lost.
Right. So, okay, so I'm practicing this. I'm going to, this is the one with the water in it to start. All right, so I'm going to do the switcheroo.
Okay.
Ready to watch?
I'm watching.
Nicole and I are both originally from near New York, so this is just Coney Island all over again.
I didn't realize you didn't know I was from Staten Island.
Well, I knew you're from the New York area, but I hadn't pried. You know?
I didn't probably realize, like, oh,
But now, well, I shouldn't have mentioned because now I want a nuisance hot dog. But all right, we're cool. Okay. So which one is it?
Do we want to label them 1, 2, and 3, or can you point them and
So
people can yell in the comments?
2, 3.
3. Okay. I know there's like a delay.
2, 3.
But I'm curious to see what the people in the comments say.
2, 3.
Come on, Michael and Guido and James.
1, 2, 3.
There's a broadcast delay.
Oh.
So it's which made Mad Libs really fun. I'm gonna say I got distracted when we talked about New York. That was on purpose, wasn't it?
Hey, look.
That was on purpose. I got distracted. I'm gonna say it was 1.
1?
Yeah.
All right.
You guys can keep commenting.
So what I'm gonna do is I'm going to take this rubber band off, and if
Jesus.
you're right,
Move my stuff.
I won't let it get too far. Ready?
Okay. Yeah.
1,
Yeah.
2, 3. No.
Oh, I'm bad at this.
Okay. So not 1. So 2, 3. 2, 3. 2, 3.
I don't think I had a predetermined bias, so the Monty Hall problem does not apply.
Monte Carlo. That's what you.
Monty Hall, right?
No, I know, but try the Monte Carlo.
2.
2. Right here.
Yeah.
Okay. All right. So.
If they're all empty, I'm gonna be annoyed.
They can't be empty. You saw me pour water in.
Yeah, but you're tricksy.
2, 3. No.
My desk is still dry.
So okay, so it's
lose.
got to be this one.
All
So
right.
this one, because you must have gotten it right, I'll do it over the trash can. So all right.
There we go. Okay, over the trash can. Must have gotten it right. Guido says 3. That was 3. There was a. Where did you put it?
Okay, so
Yes.
this is also discrepant event
Can I see what's in the
inquiry.
cups? Can I see what's in the cups now? Can I see what's in the cups?
You saw what was in the cups.
No, you had something like absorbent. I win. I win even though I lost.
So there are, there are questions to ask.
Yes.
This is the inquiry.
Right.
Pretend
you're not a smartass like me.
So it was just tap water.
Mm-hmm.
I can do this even where I show them where I fill the tap water. They know what Dixie cups are. They know what aluminum foil is. They know what rubber bands. They know how gravity works. So the only thing that works is that there was something in there to begin with. So in this one, there is, let me see.
No.
Something.
Oh, it's like gel. No, it's like, ooh. Oh, okay.
It is a type of substance called a hydrogel.
Yeah!
And this particular one is called sodium polyacrylate,
Okay.
which is A, fun to say, and B, fun to play with.
Squishy.
It is squishy. So, Nicole, or our viewers at home,
Yeah.
what do you what do you think sodium polyacrylate gets used for?
Absorbing liquid.
Absorbing things? Yeah, absorbing liquid.
Is it like those little packets of stuff you're not supposed to eat?
Those are, those are desiccants, so that's related.
Okay.
But I don't think that's
My
sodium
ignorance is
polyacrylate.
showing.
Here's a clue.
Okay.
We'll probably be talking about their main use tomorrow around noon.
Something with babies. Oh, diapers.
Yeah.
Oh, okay. Sorry, we're having a little baby shower in here
There's
tomorrow.
a baby shower at the office tomorrow. So this stuff
Michael
is...
wins. He says something absorbent.
Yeah.
Good job.
So this stuff, if you take a dry diaper and you tear it open, there will be a layer of kind of cottony stuff in there, and
Yeah.
also some little crystals that look like. Oh, it's probably easier to do
Oh,
this.
you've got to dry. Okay, I was wondering how much of it was in there. Okay.
Not much.
Yeah.
Not much.
Instant snow. Why does it say instant snow?
Well, that is also another use for it.
Okay.
For if I add some to this stuff in here, this is another type.
Oh, okay.
Then it doesn't.
Oh, it's bubbling. Sorry, you guys can't see. I'm like, whoa, look at it go.
It doesn't make.
Oh, it's not really doing anything anymore.
It doesn't make this hard packed stuff here.
Oh, I see.
It makes fluffy, wondrous stuff, which they use in Hollywood movies when they need fake snow.
Oh, so I could put this around my Dickens village.
Yeah, you can.
Well, except for the cat.
So they'll take this stuff and you can make, with this amount of instant snow, you can make this amount of snow. And somebody was explaining to me two different forms of the chains gathered together. So sodium polyacrylate, the first stuff we had kind of looks like this. And then Michael mentioned silica gel. Silica is the desiccant that's in the packets and clothes. It doesn't swell as much, it just sucks in the water. So sodium polyacrylate crystals look like this, and when water comes, they go whoop, and they hold the water in the middle, so it doesn't get out, but they have to swell up a little bit.
Which is this stuff.
Yeah, the first stuff, the stuff that's packed.
The diaper stuff.
This is the same kind of stuff, but instead of going, it goes whoosh, so it makes like a flake.
Okay.
And it's nice and fluffy, and you can let this sit, and it'll get, if you bake it, it'll get to look back like it used to. But if we let this sit overnight, it'll be little powder again, because it dries out. So this stuff is in this class called a hydrogel. Silica, I think, the silica gel, I think, is in that class too, but it's just stuff that does this motion to trap the water. Yeah.
Cool.
So
Guido actually said, I wanted to say a piece of diaper in the cup. Having the delay, 20, 30 seconds. He's in Germany, by the way.
Oh,
so
that is quite a delay.
So there you go. The extra speed of light photons to get to Germany. So thank you, Guido.
So yeah, so that's something that you can make sort of a game of it, and
that's really cool.
A little less dry. Ha ha ha. I'll be here for the next time.
Oh my god. Yeah, so here's the thing. I've been living, I don't really live here, I have an apartment, but I've been living in this office for like a year and a half, and there's still stuff that I haven't actually played with, which is really fun and exciting. If you've ever seen me do a demo anywhere in the last year and a half, I've probably borrowed something from here. All those crater, well, except for the flower and the cocoa powder, I usually buy that. But a lot of the crater demos and the comet demos and the supernova, all that came from our storeroom here. So, yay, it's fun. But I'm gonna stop playing with the diaper goo and talk about something serious. So Illinois is one of the states that is looking to adopt the next generation science standards, and so science educators now have to really refocus. People who are new teachers and people who have been in service for a long time have to refocus their teaching to adapt to these new standards and new curricula that are coming out. So what kind of things are we doing in preparation for that?
Well, they have the next generation science standards, the NGSS books out now. The National Academy of Sciences published it, so there's a desktop dead tree version you can have.
We have several copies around here.
We do have several copies so that we can reference them, and also we can lend them out to teachers, so we don't have to kill so many trees. But they're really, really good. I think what's really going to be helpful for educators is all the reactions to it, which are going to be people writing books on, okay, so if you want to do lesson planning with these, this is a way to do it. If you want to do field trips with these, this is a way to do it. If you want to do professional development with these.
So these are the supplementary materials that are being created now, I guess, now that they're actually finalized.
The user guide to the NGSS. And so it's not, um, I don't know, it's not the Wikipedia of science standards where it's just super easy to use and just catches on immediately. Like,
there are colored charts.
There are colored charts.
It intermeshes.
Some people like. I like colored charts.
I know, it's a lot of them.
Well, I like them, but they are sort of dense to navigate.
Yeah, that's
so that's where these user guides are going to be great. But in a nutshell, the really great things that this does is to first of all pare down the topics, so that you aren't doing so much minutiae like on everything. It's not so critical that you have 20 different metrics on how well they're doing with cellular biology, also evolutionary biology, also zoology, also botany. You can just say life sciences, and then we're going to sort of cover the foundations of that. And also there are a lot more interconnections with this. They're on those colored charts for every grade level and topic. There's one column that's cross-curricular connections. So that's looking at how do you promote literacy with this topic? How do you promote math skills? How do you connect to reading comprehension? All this stuff. And also the topics change. There's 3 topics. There's physical sciences, which includes engineering, life sciences, and earth sciences.
Earth and space.
Earth and space
ESS.
sciences.
Yeah, that's the one.
I remember that it was ESS, and so it's earth sciences.
And then there's engineering, which is kind of a 4th topic.
I think it's included,
weaved, but then sometimes it has its own, like in some of the high school standards.
I have, yes.
This is where it gets confusing.
Right, and the upper levels, they separated out a little bit. Yeah. But they have a lot of the same topics. So they'll have, instead of each being sort of its own territory with its own set of rules, actually sort of realize it's sort of like we were talking about with the moon, like it's all the same stuff, just different environments. So there will be systems, and they'll talk about systems with physical sciences, and so in 5th grade, maybe when you're doing physical sciences, you're looking at systems like bridge systems, and looking at a trestle bridge and how that shares weight and doesn't collapse. Then you look at systems with the body, and you look at the digestive system and the immune system, and then you look at systems with geology, and you look at the rock cycle and the formation of the solar system from cosmic dust. So you look at all these systems and show how systems is a scientific topic and how it relates to foundational material and all these different subjects. And so it's a big part of looking at the nature of science, so that you really get that science courses in schools are less about memorizing and writing down all the vocabulary words, and more about understanding why you're looking at this and why you're looking at it in this way.
It's interesting because I think that sounds like a good thing, but I've actually had some people who don't like the NGSS. They think there's not enough science content happening. Where do you stand? What do you think about it from looking at it? I mean, neither of us were trained as teachers to begin with. We're seeing it more from a scientific background, but I'm curious what your take is on that.
Well, I think that it will be immediately difficult to transition, and so maybe you won't get as much. You won't get into some topics in depth like you would before. Other topics you'll get more in depth, so there'll just be some trade-off. But overall, I think if you ingrain these scientific concepts and the foundational stuff with students, then you first of all give them the tools to look into those topics on their own. If they're really interested in dinosaurs, then they have tools to systematically teach themselves about dinosaurs, instead of needing you to teach them dinosaurs. So even if you don't have time, they can do it on their own. And also you should
have the internet, which I didn't have as a kid.
Right.
I didn't have television in high school. I mean,
And
But you have to learn how to research.
Yeah.
Even there.
Yeah. And then if you want to be a scientist, from kindergarten are doing things like professional scientists do. And so that will help you if you actually are interested in going to the field. And doing this sort of, projects that it takes a lot of pressure off teachers, I think. They don't need to have, it's not the days where your teacher was a font of knowledge and you walked into the classroom and absorbed it all like a sponge, and then they closed your head back up and like a diaper. They closed your head back up and you walked off.
Yeah. Which doesn't seem to work that way. That doesn't seem to be how humans learn.
It's not how humans learn.
I think education research has showed us that it's not the best way to teach. And some people do, but not a lot of us.
It's been something that people have known that's not how people learn for a while, but it's not something that they could do much about because you still need to get all the knowledge from it. In the 19th century, they knew that this was not just scooping knowledge. Yeah, Dewey, who did the decimal system. Talked about you don't just like scoop knowledge. You got to teach them how to be knowledgeable learners. But you still needed to absorb all this knowledge because otherwise how would you know?
Right.
But that's not really true today. If you give people foundational learning materials, then they can look up on smartphones. They can get the knowledge somewhere else to build on the scaffold that you start them with.
Or have a discussion even. But you can communicate with people across the globe like you couldn't before.
And the transitional period in between there is really tricky because kindergartners of 5 years ago were not getting a strong foundation, but they were having access to the internet, so they would build it on these things and it would partially collapse, and then they'd make up stuff to do it and fill in gaps on their own and have incomplete knowledge. And so I think partially the NGSS is a acknowledgement that we're in an information saturated age where we need to focus on shaping knowledge, not just shoveling it at people.
Anymore. Okay. And then this is going to change how teachers approach their lessons. Some teachers who've been in the field for 5, 10 years, decades.
In states where it's
where it's being adopted, or in states even, it may even be affecting the other states too. How they teach and how they change what they're doing in the classroom.
I think it will, but thinking of teachers I know and thinking of what I would do with it, I don't think it means that they're going to be teaching different stuff. I think it means that they can drop every teacher I know, including my mom, who's a teacher, has those lessons that they're like, I don't even know why I do this. I'm really, I know the standardized test is coming, but whatever. And they can drop those now because really that's just a content lesson that they need to memorize the tiers of classification of biological creatures. So we can drop that and do the lessons that they already know work well. And this will show them this is why that works well. So they can pour that knowledge over to other lessons. And I sort of picture putting all your lessons on sticky notes and putting them on the NGSS fields and saying, well, I got 90% of this covered. I just got to come up with a lesson that does this one, and I'll do it similar to the lessons that I liked and I knew were effective anyways, and I now have tools that are helping me understand why that was effective, and this new one can also be effective.
Yeah. A lot of what we're doing we have some in-house curricula here with STEM Center and a handful with CosmoQuest is we're looking at them now going, oh yeah, these fit the standard, this, that, and the other one, or we can pick a topic. So yeah, like you said, you can use the same lessons. But I hope it gives teachers more time to be able to do more hands-on inquiry-based stuff.
Yeah.
Like the diaper. I'm just gonna call it the diaper.
And teachers like that, students like that, and having it as part of your standards means that schools will treat it in a meaningful way. It doesn't seem like a line item anymore. It seems like something
It's
that
actually
should be
integral.
core.
Yeah. All right, we are pro NGSS here.
We are.
So Guido says amen to the memorizing versus understanding, and James says too, because he's apparently really behind.
He's still in the shell game.
Yep.
Well,
Want to do another one?
I'm gonna get.
And meanwhile, I'm gonna take my iPad out. I think it's in here.
I want to try and give a.
Yeah, we'll do that after. We'll see if I can get it connected.
We can skip the areas that are packed, but.
Yeah, that's true. That's why it won't be
So
much.
I'm gonna do something fun, and I hope it works because sometimes it's tricky. But
Okay.
I've got.
My favorite thing in the world. My second favorite thing in the world.
I have a terrestrial comet, dry ice. So I'm gonna put it in some water.
Hang on. Wah!
And I like this
Liquid
water.
nitrogen is my first favorite thing.
I like this water. I like this water because, or I like this bowl because it's clear. So if I put it in, and it starts bubbling, you get stuff everywhere.
I've used this bowl for things before. I don't remember what.
For
Probably
things
Comet.
I should be worried
Probably
about.
Comet.
All right. I've got a piece of string covered in soap.
Okay.
And I'm going to attempt to do.
What?
No.
What's
I'm
happening?
going to attempt to make a bubble.
Oh, cool! Sorry. I'm way too excited.
Mostly this is an excuse to get soap all over your desk.
It smells like soap. I'm okay with this.
It does smell like soap.
This
might be
the
too
second
wide
time
of a
this
bowl,
month.
but
The second time this month that I have dry ice on my desk. Oh, what's it doing? It's actually spitting at you.
it is. Okay. The bowl is too wide.
Aww.
So what I'm going to do instead is this.
We can't see what's happening under the smoke.
You can see under there.
Oh, I can see the water.
Here.
Oh my gosh! Smoke bubbles.
Oh, that's why I had those paper towels over there. For this reason. Womp womp.
Don't touch my desk.
There's already soap all over your
I
desk.
know. Okay, don't touch my keyboard. Look
This
at
is
that.
a good
Look at that.
Halloween. We're slightly behind the times, but this is a good Halloween thing. Call them ghost eggs. This is sort of ghost frog eggs. But you
Yeah.
can get something, if you get a smaller bowl, you can get one big bubble that rises like this and then pops all at once.
Oh, wow.
And you can also get a tube, and if you have the fog coming through a tube, you can dip the end in and make little bubbles that sit on the table.
It's not even that cold.
So I think Nicole knows, but do you know what this fog is?
We could wait for like 20 minutes for the comments to catch up.
you could just say, where's the fog coming from?
It's carbon dioxide.
Well, the opaque stuff in the fog
Oh.
is not.
Oh, well, it's the is it water vapor condensing out of the air?
Yes. Yeah.
Or sort of not condensing, but yeah.
Yeah. A lot of people think because you get it when you put dry ice into water,
Right.
they think somehow the dry ice is making water from the bowl rise up, but it's not. It's just the air right above the water is really saturated with water, and the dry ice cools it down and makes a fog.
Bubbles like in a mad scientist lab.
This also gets used a lot in Hollywood to make fog for atmosphere and also for acid effects. So when somebody gets, dropped into a tank because the Terminator pushed them,
That makes sense.
it makes this.
Oop. I'm having issues. There we go. And I don't know if the microphone is actually picking up the sounds of this.
Oh yeah. It's very
Soothing.
yeah, sort of a white noise, and this is how the Ninja Turtles got mutagened. Way.
I'm so glad we have the same cultural touchstones. As you can imagine, this office is a little ridiculous at times.
Sometimes, yeah.
If you want to wipe your hands off,
Let's see.
I will try and get the mobile version going. And also, so I shared a picture yesterday of sometimes I walk into this office and I never know what I'm going to see. And I walked into the office with Colin and Sean Herbert, who was in the second episode of Learning Space, just hunched over these cups with this fog going everywhere, and they were carbonating their coffee and tea with extra dry ice that was left over from something, I don't know what. And trying to keep it from going all over the STEM center. So sometimes, even lunchtime, we're goofing off and doing some ridiculous things.
It turned out all right.
It was a little. I mean, when Jack said something about something that actually
Carbonic acid.
Carbonic acid changes the taste of what's going on anyway.
Yeah, acids taste bitter, like when you leave coffee brewing too long or you oversteep tea.
Mm-hmm.
So adding carbonic acid from the dry ice, solid CO2, means extra acid. I don't know where I'm going with this. There's no room in my cart.
Oh, well. You leave it on the desk. I'll clean it up later. Since we are already at an hour, I'm going to, let's see, I think I have the iPad working, so let's try just giving people an idea of the storeroom. I hope you guys can hear me. Hello? Okay, the audio is working. You can hear it coming out the other side. How do I turn the camera around? Okay, there we go. So of course we're mid-packing because we're moving to a different spot on campus soon.
I was bragging about the organization, but it's...
all of these are empty. It's really sad. All the bookshelves.
It does end up... This isn't the cleanest part
There's
either.
a sign.
We do work at STEM. So these are all of our goodies. And we have a bunch of kitchen supplies over here, a lot of the consumables, all our vernier probes over that way. We have astronomy down at the end there. And then geology, environmental science, which is sort of the bridge to biology. And then chemistry.
Owl pellets.
Owl pellets. Owl barf.
Yep.
Chemistry, including polydensity bottles, and physics, a lot of electricity stuff here, and then math stuff and sort of toys for demos and things, and then our outreach at the end.
Hey, yes, these are the kits that go with specific outreach projects.
And we have this table in, so these are all the things that
Holy
people
moly.
have returned recently.
So these are the
all
recent
the things that
returns.
people are borrowing soon.
You guys do have a system on this table.
Rockets, flashlights, and then...
Who's doing rockets?
A teacher who went to a NASA workshop with some kids in Huntsville, Alabama.
Cool.
And they made rockets, and they didn't get to launch them all, so she wanted to launch them when she came back.
Okay.
So she's borrowing the
think I
blast
remember
plates and the igniters.
I think I remember that phone call. Awesome. So this is our fun little STEM center. Yes, you got a brief look at this if you answered our survey and saw that behind the scenes video. But this is where I stand and stare at the bins and try and come up with new demos and take things to conferences. So this is just one lab, but there's like wet labs back there with.
There's a wet lab, but that's really packed up, and then there's a storeroom that is full of boxes.
That's where all the hot plates are.
Yeah.
Yeah.
Yeah, and all our robotics Lego kits, and then our new planetarium is in a second storeroom.
Yeah.
It's full of empty boxes to be filled and planetarium goodness.
And used to have an 8-inch telescope, which currently resides in my garage because I do the public nights here. I swear it's not for personal use. I use it on campus. Let's head back to the computer. I don't know how good the audio is on this thing. I swear I use it on campus, but I just am too lazy to carry it. Okay. I hope the audio wasn't too bad for that. So that's our little resource. That's just part of our resource center, the part that's not packed up yet. And I know people are trying to get in their last-minute requests for things like Science Olympiad, which is in 2 weeks.
When we move, we're going to be unable to lend for a bit, so some people are borrowing beforehand, and then we have some requests that are immediately.
Right.
We'll have to unpack first, so that they're ready.
So hopefully that all goes well.
Yeah.
So.
It's daunting, but it's all coming together.
It's a lot. Yeah.
Nicole is very dutiful in her packing. Other people, like I mentioned, have not really started.
When my brain can't work, I put books in boxes. That's what I do. so that's the only reason.
When
I've
she
gotten
starts saying
here.
books is
Bookses.
time for boxing up.
I've been up early. All right, thank you so much, Colin. This was
Thank
fun.
you. Yeah.
We made a mess of my desk,
Oh.
but no one died, so it's
Been
okay.
worse.
It has been worse. Like I still have mud on my keyboard from the comment I did for Weekly Space Hangout.
I really hope it's from the comment.
No, it is actually.
And not like
most of it is.
you come in disgusting and just get it all over your keyboard.
No, some of it is just some of it's use, but the dark spots are mud. I can track it. Anyway, thank you guys so much for watching. I will go over our schedule, then maybe I'll give you the last word. And so today is Thursday. It's an unusual night for us. So Friday would be tomorrow is the Weekly Space Hangout. Fraser Kane hosts that. I will not be in attendance as I'm going to be doing another workshop and then heading out of town for the weekend. But Fraser Kane will be going through your space and astronomy news with a whole bunch of astronomy journalists and pretend journalists like myself. And then Sunday night is the virtual star party. I don't remember the time off the top of my head. I don't know if they've gone any earlier, but there is an event. If you go to if you search virtual star party on Google+, it'll get to their page and see their event. And you can look through the telescopes of some of our amazing amateurs who hook up their webcams and image software. There will be no astronomy cast on Monday because Pamela's in Indonesia speaking at a young astronomers, I don't remember the whole acronym, but a young astronomers conference in Indonesia. So they recorded an extra episode this morning. You can go back to the Astronomy Cast feed and check that out. And then Wednesday back around is Learning Space again, where we'll be talking about science at sci-fi conventions. So check that out. That's our schedule. That's what's coming up next. Colin, do you have a last parting thoughts about STEM?
Yeah, well, I want to thank you for having me on, and I want to thank people for watching. And I think the take-home I would say is, you can do science any way you want. It could be a hobby. It could be, just something you like reading about. It could be something you do professionally. And don't let anyone tell you when you can do science and when you can't, and what the limits of science are. If you want to study biology in space, then study biology in space.
Yay! You do citizen science too?
Yep.
I know most of you guys already do. All right. Thank you so much, Colin.
Thank you.
Thank you, everybody, and I will see you next week. Bye. Whee! Hello, everyone. Welcome to Learning Space. My name is Nicole Gallucci. As you see, we only have the one window this time, which is weird for me. But that means all the text should work. So obviously, if you can't hear me, please yell at me in the comments. I'm Nicole Gallucci from CosmoQuest, and I'm here with Colin Wilson, my coworker here at the STEM Center at SIUE, Southern Illinois University, Edwardsville. And we are going to be doing some science demos and talking about science resources for the classroom and for informal educators, and especially if you're in Southern Illinois, how you can get that stuff from us. This guy's awesome. So we are going to get started. First, I want to remind you guys, you can share the link. That will be awesome and help us out a lot. You can leave us a comment on YouTube. I'll be checking that. Hi, James. And, oops. And on the Hangout page itself, but if you guys can maybe keep it in one spot, decide amongst yourselves. And then the Q&A app for Hangouts as well, so you can interact with us, say hello, leave a comment, ask a question. That'll be really cool. So let's just get started. I know you have lots of fun demos, science demos.
I do have some demos planned. So
what's science?
We have a bunch of stuff here at the Science Center, or the STEM Center, so I just grabbed some that looked like they'd be fun.
Yeah.
So this is the fun one that I do a lot with educators. So, people watching Learning Spaces probably know the answer to some of these. So I have a ping pong ball, and I'll just ask Nicole. It says China on it? I assure you it's a ping pong ball.
It's a ping pong ball, not China.
Not China. They are hard to tell apart sometimes, but if I drop this ping pong ball / China, it's going to go, Nicole, up to my hand, farther than my hand, lower than my hand.
Lower than your hand.
Lower than my hand.
That's my hypothesis.
Right.
Yeah, I didn't even make the video.
It got a little bit up there.
A little bit? Okay.
So,
let's try it again.
So,
yeah. Go just above the lower third.
Not quite, not quite. So that's something called the conservation of energy. I drop it from a certain height, and it goes down, and it retains some of the energy, but a lot of the energy is lost. So that also should happen with this thing. It's a little popper. Oops.
Rubber thingy.
It's already popped. It's a little rubber cup, and if I...
Why don't you tell us a little bit more about your background in science education?
Sure. I recently started at the STEM Center. I started in August.
Yeah, you're a newbie.
That's true. So I started just recently here. Before this, I was at the Science Center in St. Louis. And before that, I was not an educator at all. I was a researcher. I figured, I liked science so much that I wanted to be doing it all the time. And so I actually had a rotating series of things that I wanted to do. When I was a little kid, I wanted to be a paleontologist, no questions asked.
There's a They Might Be Giant song.
Really?
About that.
About that?
Yes.
Because everyone
I'm
likes
a paleontologist.
Yeah. I was like really serious,
Yeah.
and I also was not big on looking up pronunciations, so I still have a lot of weird pronunciations for dinosaurs. But my brother and I we're both really, really interested in it. My sister's studying paleontology now, so it's in the family.
Cool.
So I definitely want to be a paleontologist. There was nothing else that was interesting to me. And then I took a really awesome astronomy course in high school with my teacher, J.R. Kandasta, who was amazing and got me really, really interested in astronomy. So then, paleontology, whatever, I want to be an astronomer. And then I started doing astronomy and was taking some geology courses as part of it, and realized that I was really liking the geology courses and not so much the quantum mechanics stuff, which was very hard. And so I decided, okay, well, I want to be a planetary astronomer. And so I went to grad school and started doing that, and then realized, this is really great. And I was doing projects with meteorites, and it was very interesting. But I thought, I really like, for my geology courses, going somewhere and knocking something off with a hammer and taking a chunk of it. And I really like touching stuff. So I guess I just want to be a straight-up geologist.
Oh, no more. Yeah. There's no missions to Mars yet, so
Right.
I can't really fulfill that.
No manned ones.
No human. Yeah.
And I did all this. I got to my master's and kind of finished with my master's and thought, what do I want to be doing? And realized that I liked learning about all these science topics, but I really, really liked explaining them to people. Fold it inside out.
See, I'm not making it up.
Yeah, there's China.
Right.
This one says 5. This is 5.
Okay.
So if I drop 5, like so, it's going to pop and also
it just went horizontal for those of you watching at home or
it went horizontal,
on the podcast.
But again, not as far as my hand. So we lost some energy, even though this thing snaps and gives us some elastic energy back. So if we combine these, Nicole, are we going to get up to my hand, above my hand, lower than my hand? They both went lower.
Okay. So you would think together they might still be lower.
Right. So we'll try.
Ooh.
Neither.
It's broke.
Okay.
Okay, let's try one more time.
This might not be high enough. Let's try.
Yeah. Did that leave a crack? Or are those pre-existing? You didn't hear that. It just bounced off the ceiling.
I think those were there before.
Those were there before us. We're gonna go with that. So that is an example of what we would call a discrepant event.
Yeah.
Can you explain that a little bit? Because this is a term I'm recently becoming.
A discrepant event is something that so there are lots of things that are surprising, new things that are really interesting. But there are some things that you think you know the answer, and then it turns out to be something else, and that's a discrepant event. Right. So looking at the bouncing of both these things, you think you know what the combined effect is going to be, but it's something totally different. Right.
Can you tell us why this actually snaps back and goes, hits the ceiling and scares the poo out of me?
Yeah. So the reason is that this little popper thing, when it snaps, the first time I snapped it, it popped up and didn't go as high as my hand because it lost some. Not all the energy stayed with this thing. If all the energy stayed with this thing, it should leave from my hand, go right back up to the same height. But some of it's lost and it goes into the earth and shoves the earth a little bit, but that happens all the time. It all evens out. Maybe it heats up this table a little because the elastic energy turns into thermal energy.
My desk is warm.
Yeah, that's why your desk is warm. Just constantly getting it. So some of that energy is lost. When I combine them, it puts some energy into the desk / earth, but the same amount of energy into a ping pong ball, which is much smaller. It's only the size of China. So it goes rocketing up to the ceiling because it gets a lot of elastic energy. So I started working at the Science Center in St. Louis, doing education outreach stuff, and in particular there's a teen program there that's a really great program, the YES program. And I worked with teens there and covered a bunch of science topics, and then I started here and started working more with teachers to pass on that knowledge and help think of creative ideas to engage different topics.
Wow, very cool. That is very cool, and it sounds familiar.
Yeah.
I like doing science, but I really like explaining it, and having trouble keeping focus on one tiny little area of research. So I totally get that.
Like the universe.
Like if only, yeah. If your dissertation was the whole universe, you'd never graduate.
Right.
Never ever graduate. So. Awesome, awesome. So what did you do for your master's in planetary? No, in geology, sorry.
In geology, I went camping in Quebec for about a month, which was really fun, and gathered up samples in a field area of a pretty rare kind of rock called a northicite.
Okay, I've actually heard of that.
Really? Yes,
I don't know much geology, but...
You have, because it is hardly found anywhere. It's found in this sort of series of deposits, one in the northern hemisphere, one in the southern hemisphere, that if you match up the continents again, they all line up into a northern trend and a southern trend.
Gotcha.
They all, there was a period billions of years ago where there was a bunch of them that formed and then they stopped, and there were none before and none after, so it's sort of mysterious. So you can only find them in a couple places, and also like half the moon, because the highlands in the moon.
That's probably where I've heard of it then.
The highlands of the moon are all in northicite. And actually, in Jay Arkandosta's class, I should let him get some royalties for all the promotion I'm doing. But one of the things that still I remember vividly, like hearing this and thinking like, wow, okay, was there's highlands in the moon that are this white type of rock, and that rock is called a northicite. And here's a chunk of a northicite. And then, in the lowlands in the moon are basalt, and here's a chunk of basalt. And so the idea that the moon, which is this relatively airless, faraway body that's, untouchable and all this stuff, is made of the same stuff. The rules are the same there as here. Is really exciting and interesting.
Cool. Very cool. So what brought you here to the STEM?
Pumped into it, which before it was deceptive how the amount of energy we had because it was going into something huge and relatively immovable. The Earth shift
under China. Yeah, so we have lots of fun little and not so little things like that around here, and although I live here at the STEM Center, we don't get to talk about it much on CosmoQuest, so I'm excited to talk to you about that. Maybe you can tell us a little bit about what the STEM Center is and does.
Sure. So the STEM Center...
STEM is science, technology, engineering, mathematics. I know that sounds like I'm over-explaining for some of you, but some of you may not be familiar with that. So let's say that first.
I was going to do the same.
Oh, okay, there you go.
I learned recently that when it first got proposed by the National Science Foundation, they were calling it SMET, which is the same letters, and they just say, well, we'll just put them all together. And somebody said, it'd probably be better if it's an actual word. And STEM has connotations of growing and learning and students. Yeah, and SMET sounds awful.
Sounds like smut. Terrible.
So at the STEM Center, it's a research center. So we do things like CosmoQuest, where we have citizen science projects that are actually generating new science. It's a education center where we assist teachers. That's a lot of what I do. And have resources for them, have curricula for them, have different things that they can try in their classrooms to improve their students' experience. And then we have outreach as well, which is actually going out and delivering. So we have people who go out and will do after-school programs, who will do sort of cameos in classrooms, who will do professional development for teachers. That's something that I do too. And so we just generally try to engage all the educators and community in Southern Illinois with different STEM-related topics.
Yeah, it's a great resource, and kind of wishing I could take the camera back to the storeroom and show everyone. Maybe at the end I'll try on my iPad, because it'll probably break everything, but we'll do it later. It's like this magical wonderland of science toys, and where last place I worked, we had a little closet of science toys that we used for our astronomy outreach. This place is just like...
The last place I worked, we had a large room like this, but it was very messy and all over the place. So this is both organized and large.
Yes,
so.
Thank you, Elizabeth, who was a recent Learning Space guest who helped us organize a lot before you came. So, yeah. So